The last topic we did, topic number 14, was we were graphing parabolas or graphing quadratic equations in standard form. And what the standard form that we were used to was y is equal to ax squared plus bx plus c. Today what we're going to go over is the root form of the quadratic equation, which is a little bit different. It's f of x, or y, is equal to a times the quantity x minus r1 times the quantity x minus r2, where the roots of the equation are r1 and r2. Those are the zeros. The roots are the zeros. Okay. What we're going to do is we're going to take an example number 1, and we're going to try to figure out everything. Okay. Example number 1, the equation is f of x is equal to negative 2x times the quantity x minus 4 times the quantity x plus 6. All right. First question to ask us, what is the direction of this parabola? And the direction of the parabola is determined by this term here. Like in the previous equation, A told us the direction. If A was positive, it pointed in the up direction. If A was negative, it pointed in the down direction. So since this is negative 2, the parabola is going to point down. That means your parabola is going to point in the down direction because it's negative. All right. Next question is, what are the roots? It's very easy with this equation. We need to solve this term for 0. So in order to do that, we say x minus 4 is equal to 0. Therefore, x equals 4. Okay? We do the same thing with the first term. The second. We get x plus 6 equals 0. And if we solve that, we get x is equal to negative 6. The way we write that is we write the roots as 4 for x, 0 for y, and the second root is negative 6, 0. All right? Now we go on and we have to figure out the y-intercept. The y-intercept in the standard form of the equation is told to us, which is c. That's where I scratched earlier. And in this, we're not given a c, so we have to calculate it. In the standard form of the equation, we had to do the calculations. We were coming up with all those nasty fractions. Well, in this one, we're not going to come up with many nasty fractions. What happens is we have negative 2, and we know that the y-intercept, x is equal to 0. So we're going to plug into 0 into our formula. And we've got 0 minus 4, and we have 0 plus 6. Okay. Now all we have to do is some simple math. 0 minus 4 is negative 4. And 0 plus 6 is a positive 6. And we're going to multiply that by our 2 that we have out here. 2 times negative 4 is negative 8. Negative 8 times 6 is negative 48. Okay? That is our y-intercept. So we're simply going to write it down, 0 minus 48. That's all there is on this type of an equation. Okay, example number 2, same process. What we're going to do is we're going to fill in the blanks. Since 1/2 is positive, okay, the direction of the parabola is up. So what that means is your parabola is going to look something like that because the first term, a, is positive. To figure out our roots, just like the last equation, we're going to do x plus 4, that has to equal 0, or x plus 2 has to equal 0. When we solve for this, we get x is equal to negative 4, And solving this one, we get x is equal to negative 2. So we're going to write down our answers. We have negative 4, 0, and negative 2, 0. The hard part was calculating the y-intercept. And once again, the way we do that, we take our equation 1/2, we plug in 0 for x, because we know at the y-intercept x is equal to 0, and we do it for the second term, and we get x plus 2. All right, now we have 4 times 2 times 1/2. Half of 8 is equal to 4, so our y-intercept is simply 0, 4. I think you guys are going to find that this form of the equation is much easier to work with. Moving on to example number 3, it's a word problem. We all hate word problems, but it's not that bad. First thing that I would suggest that you do is to write down the root form of the quadratic equation, excuse me, which is f of x is equal to a times x minus r1 times x minus r2. Now what we're going to do is we're going to pick out the information from the word problem and try to solve it. First thing it tells you, we have a root of negative 2 and a root of 3. Okay, so R1 is equal to negative 2 and R2 is equal to a positive 3. Okay? It also tells you that the y-intercept is equal to negative 12. So what we're trying to do is we're trying to take the information that we have, plug it in to our equation, and come up with the form of the quadratic equation. So first thing we're going to do is we know that y is equal to negative 12, so we're going to write it in here. And next we have a. We don't know if this guy is pointing up or down. We're going to plug in our information. So for the y-intercept, 0 is our x, and we subtract negative 2, okay, which is the same thing as adding 2. And then we're going to plug in 0 again, and we subtract r2, so we subtract a positive 3. Now all we have to do is multiply everything out and see where we come. We have negative 12, okay? A times positive 2 is 2a, and then we multiply that times negative 3, and we get negative 6a. All right, we're trying to solve for a, so we're going to divide both sides by negative 6, and a is equal to a negative 12 divided by a negative 6, which is equal to a positive 2. Okay. We now know what a is, so all we have to do is plug all our information into the equation. We have f of x is equal to a, which we just calculated, is 2. We're going to multiply that by x minus root 1, which is minus a negative 2, which is the same thing as positive 2, times x minus our second root, which is equal to 3. We now have the equation that fits the data above. Okay, now moving on to example number 4. We're going to take the information we can out of the word problem. It's asking us to write the equation of a quadratic function with x-intercepts of 4 and negative 4 and a y-intercept of 6. Well, the x-intercept of 4 means that our coordinates are 4, 0. Our other x-intercept is at -4, 0. Okay? And our y-intercept is equal to 6, so our y-intercept is going to be 0, 6. All right, now that we have this information, we're going to try to plug it into our equation and solve for a. Remember that this is x, this is y. Remember that this guy is root number 1, and this guy we're going to call root number 2. We're going to try to figure out what a is now. In order to figure out a, we're going to plug in our y is equal to 6, a, and remember we're at 0, so we have 0 minus 4 times 0 minus a -4 is 0 plus 4. All right, now it's a pretty simple process. -4 times +4 gives us a -16a, and -16a is equal to 6. We're going to divide both sides by 16, so we have 6 over 16, and it's negative, equals a. We can reduce that fraction to -3/8. Okay? So we know that a is equal to -3/8. So all we have left to do is to plug it in to the root form of the quadratic equation, which is f of x is equal to a, which is -3/8. That tells us that the graph is pointing downward. We're going to multiply that by our two roots, and our two roots are x minus 4 and x plus 4. We now have the equation, quadratic equation, that describes the information listed above. Okay, and now moving on to the last example, example number 5. Example number 5 says, write the equation of a quadratic function with zeros of -3 and 2 and a y-intercept of -1. So the information that we can gather from that is that R1 is equal to -3, R2 is equal to a positive 2, and our y-intercept is -1. Now we have our information. We're going to plug it into our equation to solve for a. So y is equal to -1, and that is equal to a times x minus a -3, which is the same thing as x plus 3, times the other root, which is x minus 2. Okay? I should have plugged in 0 for x. I didn't, so I'm going to go ahead and show you that. We have a is equal to 0 plus 3, which is 3, times 0 minus 2 is -2, so we have -2. -2 times 3 is -6a, and we know that -6a equals -1. We solve for a, and when we solve for a, we get a is equal to 1/6. It's positive. Now what we do is we take that information and we plug it into our standard form, or not standard form, our root form of the quadratic equation, and we get f of x is equal to 1/6 x plus 3 x minus 2. And we have our equation. Life is good. Now we do our homework. Okay? Thank you.